Concept 15 is solving rational equations. You've learned two methods to solve rational equations. One method is to find common denominators, and the other method is cross-multiplying. In part A, this is an example of where you can cross-multiply because there's only one fraction on the left side and one fraction on the right side. So cross-multiplying would give us x times x minus 4 equals negative 4 times x minus 1. Now we have an equation with no fraction, so we can continue to solve. X squared minus 4x equals negative 4x plus 4. In this case, negative 4x, those cancel. X squared equals 4, so x is equal to plus or minus 2. Make sure to check for extraneous solutions, meaning when you look at the original problem, does each of the solutions or either of the solutions make the denominator 0? 2 and negative 2, neither would make the denominator equal to 0, so both of these are valid solutions. Alright, on part B, if you were to solve this by cross-multiplying, you would have to subtract the 1 over here first. So let's do this one using common denominators. Here we have a denominator of 1, but we're missing these denominators. We're missing a 6 and an x minus 1. So same thing on the top. On the second fraction, we're missing the 6. And on the third fraction, we're missing an x minus 1. Once all denominators are the same, so in this case they're all equal to 6 times x minus 1, we can rewrite the equation without the denominator. So 6 in the numerator, parentheses x minus 1, plus 5 times 6 is 30, equals 7 times the quantity x minus 1. Now that we don't have any denominators, we have a much easier equation to solve. So 6x minus 6 plus 30 equals 7x minus 7. So x equals 30 minus 6 is 24, add the 7 over and you get 31. Here on part C is another example of an equation where we can cross-multiply since we only have one equation here and one equation here. So cross-multiplying would give us this equals 4 times the quantity x squared minus 4. If you recognize that this fraction is factorable, you could factor first. So in this case, if you factor first on the left side, you take out a GCF here and difference of squares here. You can cancel these and then you have a simpler fraction, 3 over x minus 2. But either way, even if you don't recognize that, you can multiply the original expressions as well. So in this case, if we do distributive property, we get 3x squared minus 6x plus 6x minus 12 equals 4x squared minus 16. These cancel, so we have 4x squared minus 3x squared is 1x squared. Negative 12 plus 16 is 4. If x squared equals 4, x equals 2 or negative 2. We need to check for extraneous solutions, so we're plugging back in to see if the denominator becomes 0. If we plug a 2 in, both of these denominators become 0. If we plug a negative 2 in, this denominator becomes 0 because negative 2 squared minus 4 is equal to 0. So in this case, neither solution is valid, so this is a no solution.